In the notes for 10.6, we're going to be looking at some special cases of factoring. So there are these two different kinds of patterns. These are one example, and then this is the second example of times when the factoring works out to be just a little bit different in terms of the number patterns that you see. But on both of these two different new ways of doing the factoring, or two different patterns for the factoring, I want to point out that you're doing the same thing. It's still a T-chart. It's just the way the numbers work out that's a little bit different. So in these first two, when sometimes the numbers work out so that they match exactly. And so when that happens, you could write this as 2x plus 5 and 2x plus 5, but we write it as 2x plus 5 quantity squared. So the squared just means that there's two of these and they match exactly. Same thing on this one when I factor it. The numbers that work out in the T-chart are 2x minus 5 and 2x minus 5. And so when I write my answer for that one, I do 2x minus 5, and again, quantity squared. So this is the way that you'll usually see the answers for these written. Anytime you see the squared, remember it just means that there's two of them. And then this one's a different kind though. On this one, notice the 4x squared, notice the negative 25. It's a minus sign on the 25, that's important to recognize. But then notice how there's no middle term. So like right here, there's no number that just has the x on it. There's no x term in the middle. That means that when you crisscross across, the numbers need to cancel out. So when we're doing our T-chart and we recognize it's to this pattern, we're going to put a 0 in the bottom. The way to make these cancel out would be to have 1, 5 be positive and 1, 5 be negative. That would give you positive 10x and negative 10x, and 10x plus negative 10x would give you 0. When you write your answer for these ones, you can't write it like you did over here with the squared, because you see how one of them has a plus on the 5 and one of them has a minus. So when you write these, you just write it out the long way. One of them gets a plus, one of them gets a minus, and it doesn't matter which one goes first and which one goes second. So in the first example, in A, B, and C, these all have two parts, and so they're all going to be examples of this difference of two squares that we practiced up above. Notice that when you make your T-chart, you're going to put a 0 in the middle because you want the crisscross to be opposite so that they cancel out. And then for this one, it worked out to be x plus 2 and x minus 2, because 2 times negative 2 gives you negative 4, but then 2x plus negative 2x gives us 0. So we want them to match exactly, except they're going to have opposite signs. The pattern always is you try to hockey stick or GCF first, and if you can't do that, then you T-chart. And so on this one, oops, I forgot the 5 right here. I'm trying to T-chart it so that the numbers on the left, when I multiply them, I want it to give me 25m to the second, and then on the right, when I multiply them, I want it to give me negative 36, but when I do the crisscross, I want to get 0. So that means that the numbers need to match exactly. 5 times 5 gives me 25, 6 times 6 will give me 36, but I want it to be negative, so I need one of each. And then let's check and make sure. 6 times 5m gives me 30, 5m times negative 6 gives me negative 30, and positive 30 plus negative 30 gives me 0. So that's how I know I did this one right. And so they match exactly, except the sign in the middle is different. This is called the difference of two squares. By the way, notice that they have minus signs in the middle. That's important to recognize because they do have to have minus signs for these problems. On letter C, there's a step I have to do first. Both of these can divide by the number 15. So remember the pattern from the other day. I hockey stick, I take out the GCF if there's a GCF to take out first, and then the pattern says I always try to T-chart what's left over. So x times x gives me x squared, and then positive 1 times negative 1 would give me negative 1, and these numbers are opposite, so positive x plus negative x would give me 0. When you write the answer, don't forget that that number that you started by taking out, that GCF that you hockey sticked out in that first step, a lot of people forget to write that down here in front of their answer, so just make sure that you include that as a part of your answer. In the next row, these ones have 3 parts. So remember, this one goes on the left, this one goes on the bottom, and then this one goes on the right. These are the ones where sometimes they're going to match exactly. Now when you look at a problem, like let's do E together, remember the pattern is you try to GCF out anything that you can GCF out to start. And so on this one, they all divide by 7. when I go to do the t-chart for what's left over, I don't necessarily know ahead of time that it's going to be one of the special ones. But as I start to try numbers, 4 times 1 would give me 4, but 4 plus 1 would give me 5. And so that's like my little hint that I want to try one of the other pairs of numbers that multiplies together to give me 4. When I write my answer for this one, it's going to look like this. The 7 gets written out front, because right here when you GCF'd it out, the GCF always has to get written first. And then it was x plus 2 and x plus 2, so I write that as x plus 2 quantities squared. The little squared just means that there's 2 of them and that they match exactly. On letter F, there's nothing to GCF out, but this is the first time that we've seen one that has 2 different letters. And so sometimes when you're doing this, let's see, 4 could be 1 and 4, or it could be 2 and 2, and then y. So it's different when there's another letter over here. Let me show you how this one works out. 2x times 2x is one of the ways that I can get back 4x squared, but then over here, they're not going to have not just numbers like they have so far. They're going to have letters. And so let's check. 2x times 2x gives me back 4x squared. 1y times 1y gives me back 1y squared. And then 2x times y and 2x times y, 2xy plus 2xy would give me 4xy. And so that's how I would know that I did this one correctly. So on this one, there was no GCF that you had to take out first, but it was a little bit more complicated of a question because you had to include that additional letter there. And so that'll happen anytime they have 2 letters in the problem and you're trying to t-chart. In this last row, the problems that we're finishing with have 3 parts. So they don't have a 0 down here in the bottom the way the first ones did up in A, B, and C. But when I do the work for these ones, I have to be careful because sometimes when this sign right here is a negative sign, it might be that they match exactly, but these 2 right here and right here might have negatives instead of positives. Let's see. So on the next one, remember you always have to try to GCF first. On this one I can GCF out a 2, and so I'll be left with y squared minus 10y plus 25. And then the rule says that after you GCF, you always try to go through and t-chart what's left over. So the 2 numbers that times to give me 25, it could be 1 and 25 or it could be 5 and 5, but they need to add up to give me negative 10. So that's how I know that those 2 numbers are going to be negative 5 and negative 5. So I took out the 2 to start, and then when I t-charted it, I had 2y minus 5s, and so I write it in that format. Don't forget that that number can come out front right there. And then let's see, for this last one, this is another one where you have to GCF out a number first. So I'm left with x squared minus 10x plus, 25. And so I need, this one's going to be similar to that last one, except it's going to have x's where this one has y's. So x times x gives me back x squared, and then negative 5 times negative 5 gives me back positive 25. They add up to give me negative 10. So that would be the format for your answer. A 3 out front because you GCF'd that out front to start, and then 2x minus 5s would be in your answer. Remember, the numbers don't always match up like this. In the notes from yesterday, we did a whole day practicing that they don't always do that. This is just something that happens some of the time. In this last example for today, the directions say determine if each equation is true for all values of x, circle yes or no for each equation. So these first 2 have been done out for you. There's a couple different ways you can go about this. You're trying to figure out, are the 2 things on the 2 sides of the equal sign equal to each other? So on this first one, I decided to leave the left-hand side of the equation just by itself, and I went through and I did the multiplication over here. So I wasn't t-charting on this one, I was foiling. I did first, outside, inside, last. And so once I simplified by combining like terms, I compared the 2 of these, and you see how the 24 on this one's positive, but the 24 on this one was negative? You circle no, saying that those 2 things are not the same, because they don't work out to be exactly the same. On the second one, I couldn't just do one side. I had to go through and I had to do the work for both sides. So on this one, 2x minus 4, I FOILed it out, and so I got 4x squared minus 16x plus 16. This side was a little bit trickier because PEMDAS says you have to do exponents before you can multiply. So I had to do the multiplication. I had to FOIL this out first and save the 2 for last. And then in this step right here, you have to do the distributive property and multiply the 2 through at the end. So in comparing the 2 of these, they're not exactly the same with what's left over, which means that they're not true for all values of x. So you say no. So sometimes you just have to do what's on one side, and sometimes you have to do what's on both sides. On this one, this side's all set, and so I'm just going to go through and multiply through what's out on this side to prove whether or not the answers are the same thing. And so let's see, on this one I'll need to FOIL, and so I'll get 9x squared minus 30x minus 30x again plus 100, and so it's going to turn into 9x squared minus 60x plus 100. And so if you compare the 2 of these, they're different because this one's missing the 60, and then this one it's plus 100, and it's supposed to be minus 100. So they're not the same. And then on this last one, let's see, I'll do the same thing. So on this one, it's the left-hand side that needs to be changed, though. The right-hand side's already simplified. There's no parentheses on it. So I'm just going to do the multiplication on this one. X squared plus 5x plus 5x plus 25. And so then, just like these two combined together in the last one, these two will combine together in this one. So I'll get x squared plus 10x plus 25. And as you can see, those are not the same. So you'd circle no for this one as well. Sometimes you have to do work on both sides of the equation, but usually, like you see how in these two, none of them had parentheses, you don't need to do the work to prove it. The other side of the equation, you can just compare what you get on this side once the parentheses are gone to this side, and over here I compared this one to this side to prove that the answer to both of these questions was also no.